Let's write a simple program that actually uses these student objects. So here's our task. We'd like to write a little program that can allow users to compare test scores of two distinct students. And again, just like we saw in the student class that we designed, we'll assume that each student has 3 test scores. Here's an example of what interaction in this program might look like. It's pretty straightforward. We first prompt for the first student's name and test scores, then we prompt for the next student's name and test scores, we print out all the information, and then we print who had the highest score and who had the highest average score. It's not a terribly complicated program, and in the past 2 lectures, we've already seen that we basically have the methods that we need in the student class in order to do these things. But for the sake of design, let's think carefully about what classes we will need for this. Our needs suggest 2 classes. We, unsurprisingly, need the student class that we looked at earlier in this unit. And second of all, we need student app, which is the class that supports our interface and which will actually declare and manipulate these 2 student objects that we're going to compare. In this example, Mary and Sam. Now, generally, we like to divide up the code for interactive programs into at least 2 sets of classes. We'll discuss a third later in the course. On the one hand, we have what we'll call the view, which is all the classes that handle any interactions with users, and that might include, let's say, input and output. On the other hand, we have the model, which is any classes that represent the data or the information that we're going to need to use in our program. It makes sense to separate these because that means that we can change one of them really easily without having to change the other. I could change how students are represented, that would be changing the model, without necessarily having to change the app that uses them. Or I could change the interaction, maybe add on a graphical layer, without having to change how students themselves are represented. Segregating those 2 functions can be a very helpful design pattern for us. So if we pretend for a moment that we hadn't already written the student class in the last lecture, well, you can sort of see the needs that emerge from our task. Well, we know we need these 4 instance variables, a name and 3 test scores. We know we need constructors, we need getters and setters, and we need methods to find the highest score and the average score. Sometimes it's helpful to represent a class's design in a box, something like this, or a diagram like this. We can see we have the name of the class, we have our instance variables next, which includes both the name of the variable and its type, and you can see we also here include a minus sign to indicate that they're private instance variables. Then we would have all the methods. So here we can see all of our methods. This plus means that they're public. So all of the methods we are declaring are public, and they are all named here. If there are parameters, we list them as well as their type. And if they have a return type, which is the case for every method except for our constructors, we list their return types as well. So here, set names return type is void. Get names return type is string. Set scores return type is void, and so on. We can see these are int, and string for these last 4 methods, none of which take any parameters. Now, that same diagram for our view class looks significantly simpler. All we have here is the class name. There are no instance variables here, and we just have one public method, main, whose return type is void, and which takes as its parameter an array of strings that we call args. You can see here we actually also underline the name of the method, main. That's how we indicate that it's a static method. The underlining tells us that it's static. So let's whip through this code at lightning speed. I encourage you to pause the video or rewind it so you can read the code a little more closely whenever you feel the need to. We'll start with the chunk at the top. Everything here looks fairly straightforward. We're just declaring our class, student app. This is our view class. We're assuming we already have the student class from last time, and we're just entering our main method. We're making 2 student objects, student 1 and student 2. We're also making a scanner that's going to read from the console, and we're declaring name and score, which are 2 local variables that we're going to use. Then we've got a paragraph that inputs the first student's data, prompting the user and getting each of the test scores after the name. We're calling set name and set score rather than, of course, using a direct constructor. We then do the same for the second student. You can see this one tricky little line of code here consuming the trailing new line character. We're actually going to talk about the need for this at a later time. For now, take it on faith, but we will treat this later. It's often a source of confusion for beginning students, so we will talk about it. Then you can see we print out the information for both students, implicitly invoking their toString method, and we figure out who had the highest score overall and print out that student's name and high score in this statement here. Last of all, we do the same kind of calculation, but this time for the average score. So we're getting both student objects' average scores, comparing them, based on that, deciding what to assign to our name and score variables, and then printing those out. All in all, a fairly straightforward program, but it is a good demonstration of how we might actually, number one, use student objects like the ones we defined in the last lecture, and number two, separate the model and view functionality into two separate classes. That's it for today.